So, currently we're in lesson 2 of unit 4, and it's about where points where two curves or two lines or two objects cross. So a system, let me make this a smaller ink here. System of equations. The purpose of these is finding the points where they intersect. So nonlinear systems they're just not straight lines. They don't have to both be straight lines. At least one of those equations is a curve. So there are curves or bends in the object, so they're just not straight lines. Now, solutions in systems, you have two or more equations. So this is a system. This is a system, x plus y equals 5, y equals x squared. This is a system. This is a system of equations. You have two equations. Also, if you have a curve and you have a line going through it, this is a system as well. There's a curve and then there's a line. So that's a system of equations. That's examples of systems of equations. So first, we're going to circle the solutions in each one of these problems. Okay? Now, let's finish up real quick. So this is it's an intersection or coordinates or a point. Okay? So we're going to go and circle the intersections here. I'm going to highlight so it's a little bit easier for you to see what I'm talking about. So I have intersection here, and then I have intersection here. Okay? Over here, I have one intersection. For the next one, there's no intersections. This one is totally coinciding. It's coinciding lines, and parallel lines have no solutions. So I'm going to go back and kind of write what's going on here. So I have solutions. I have a solution here, and it looks like I'm at -2, comma, -1. And my other solution, the other intersection, is at it's like 1.5, comma, 1, 2, 3, 4. So the other one is 1.5, comma, 4. Might be off a little bit. Over here, I have an intersection at 1, comma, 1, 2, 3, 4, 5, 6. Here, no solutions. Over here, so I want you to kind of write this x, comma, y maps onto this, x, comma, y maps onto this. And here, x, comma, y belongs to all real numbers. And we're going to discuss what that means. That means all solutions ever. Over here, parallel lines, x, comma, y, no solution. Okay? Now, it's a little bit easier to see here, so that the directions say, find the solutions to the system, identify the point, and circle the location. So, my intersection, I only have one intersection. This location, we're going to say x, comma, y, maps onto, let's see, -3, comma, -1. Over here, we have two solutions. There's one, and there's the other. So my first solution, x, comma, y, maps onto -2, comma, -3. My second solution, x, comma, y, maps onto 2, comma, 5, and I'm done. Now, down here, a little bit harder to read here, but x, comma, y maps onto, let's see, negative 1.7, looks like, comma, looks like negative 0.25. Now, the second intersection here looks like positive 2.5, comma, 2.5. So x, comma, y maps onto 2.5, comma, 2.5. Next one, here are my two intersections. So the first one, x, comma, y, maps onto, let's find the origin here. It looks like we're right here. So that's negative 1. Negative 1. About negative 0.9 actually. Negative 0.9, comma. Looks like it's right in the middle. Positive 4.5. That's the first intersection. The second intersection looks like it's at a little bit over 1, so we'll say 1.1, comma, up 5.6. That's my second intersection. So that's graphically finding those intersections. Here, we have an intersection here. You can go ahead and get those coordinates on your own. All right, so we're ready to go, and our first set of coordinates here is at negative 3.5, comma, negative 0.5. Okay, and second set over here, x, comma, y, maps onto 2.5, comma, negative 2.5. And over here we have three distinct intersections. So our first intersection, x, y, maps onto negative 2.9, comma, negative 1.2. Second intersection here, x, comma, y, maps onto 0, comma, 5. And the third maps onto the coordinates 2.9, comma, negative 1.2. Moving on. Here's my two sets of intersections here. So I have x, comma, y maps onto the first set of coordinates. We have negative 2, comma, 0, and x, comma, y maps onto positive 2, comma, 0. Next set, our last set here, 0.5, comma, 5.1 is my first set of coordinates. The second set is 2.5, comma, negative 0.9. And we circle there and there. Okay? So the next part is kind of like an overview of what you've done so far. So definitely go ahead and try those. And work on what you get. I'm just going to go ahead and put the answers there. Okay? So anyways, just check your answers. At this point, we are going to use our graphing calculator. So we're going to do a certain couple things. So first, we're going to enter our equation. So you go to y equals. You have to make sure the y is by itself. And so both of these are. And then we're going to go to find intersections. Find intersections. Right? So the first thing we want to do is just kind of look at the graph, but typically I just press zoom fit. Zoom fit. And then we're going to press seconds, trace, and we're going to go to number 5, intersection. That's what we're going to do to find the intersection. But we're also going to graph these equations. So we're going to use the table and go to second graph. Okay? So I'm going to do that for example 3 and example 4. So the first thing we want to do is grab our graphing calculators, right? And put these equations in. Okay, so I go to my graphing calculator, press clear, put my equation in, press clear again, x squared. Sorry, it's 2x first. 2x and x squared. So I'm going to go back up top and get rid of that squared. So I have 2x there. And I'm just going to press trace to see if I can see the actual graph, and I can't. So I'm going to press zoom fit. So I don't like that zoom, so I'm just going to say zoom 6. And if I look, that's what it looks like. So I'm going to go to the table and go ahead and write this information down. So what I'm going to do is write the information down here on my table. So you have 3 different columns. What we're going to do is break those columns up. The first column, the first table I'm going to have is x and y1. I'm going to have -3, -6, -2, -4, -1, -2, 0, 0, 1, and 2. This is my straight line. So I'm going to go ahead and graph those things. So -3, ups, let's see, -3, down 6, can't graph this. -2, down 4, can't graph this. -1, down 2, okay. Then 0, 0, 1, up 2, and I just keep going. So here's my straight line, right? Now, this is y1. This is y1. It equals 2x. My second table. So I'm going to erase this over here and do my second table. It's going to consist of x and y2. So y2 is this equation here. Okay? So I have -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So I'm just going to go through and try to graph these. So left 3, up 9, here's a point. Left 2, up 4, here's a point. Left 1, up 1, here's a point. 0, 0. Left 1, up 1. Left 2, up 4. Left 3, up 9. And I kind of already see some points of intersection here. So what I'm going to do is go draw my curve. And I'm going to highlight those points of intersection. I have a point of intersection here at 2, 4. And then I have a point of intersection here. So it's easy to see it when you're graphing equations. So my solutions here are are 0, comma 0. And if I look, it matches all the way across. And if I keep going, 2, 4 over here, and 2, 4 over here, and 2, comma 4. So let's try that again. We're going to go to y equals, put these equations in, right? All right, guys, so we have our table of values, so we're just going to write those down. We're going to create our two tables. Here's y1, here's y2. So for my first table, x, y1, and then x and y2. So my values might differ for each one. So for the first equation, I have -2, 19, can't graph that. Have -1, 9, 0, 1, 1, -5, 2, -9. Not a lot of good points here. 3, -11, and 4, -11. 5, -9, 6, -5, 7, 1. Okay? So a lot of points there. And then for my second one, I have, if I go back up, I have -6, -18, -5, -9, -4, -2, -3, 3, -2, 6, -1, 7, 0, 6, 1, 3, 2, -2, 3, -9. Okay? So I'm going to graph the first set here. So I can't graph this, but over 1, up 9, I can graph that. There's a point here. 0, 1, 1, -5, down here. 2, -9, right about here. 5, So here's my first curve. Here's my first curve. My second curve, I have left 5, uh, down 9. Okay. Let's see. 3, down 9. Let's see. -4, -2, -4, down 2, and 2, -2. Okay. -3, 3. So it's a little bit hard to tell. So it's a little bit hard to tell where these curves, where these points of intersections are at. But what I'm going to do is kind of highlight the 2 points of intersection. Here's my 2 points of intersection. And what I'm going to do to get to these intersections is going to be a little bit different for you probably. So what we're going to do is we're going to press second trace, and we're going to get the point of intersection 5. We're going to go to the first curve here. We're going to press enter to the left of that intersection, and then we're going to move to the right of it. Press enter again, and we get 0.76 or 0.77, comma 6.95. So 0.77, comma 6.95. That's my first intersection. My second intersection is down there at the bottom, so I'm going to assume do the same thing. Second calc. I'm going to go to number 5, and I'm going to go to the left of that intersection. So press enter. Then I'm going to go to the right of that intersection. Press enter. And I get 3.2727, negative 11.20. 3.27, comma, negative 11.20. So when we're doing these, things I want you to do. I want you to make sure, so number 1, get y by itself. Go to y equals, put in the equations. Number 3, I'm going to press second trace, number 5, intersection. And if you can't see the intersections, you might want to go back and play around with the zooms. Okay? So we're going to do the next one, 3x plus 5, and then y equals negative 2x plus 10. So I'm going to put 3x plus 5 in my calculator. Go to y equals, press clear, 3x plus 5. And then the other one is negative 2x plus 10. Press second calc. We're going to go to number 5, intersect. And I see the intersection, so I'm going to hit to the left of it, and then I'm going to go to the right of it. Press enter. And I have 1,8 as my solution. 1,8 is the points of intersection. It's as simple as that, guys. So you have some classwork to do. Recall the what you're going to be doing to get the answers, and you should be fine. Go back and look at the video if you need to. But this is classwork. It is a grade, and I expect it to be done. Okay? Let me know if you need any help with it, and have a nice day, guys.